Assalamualaikum students, welcome back to my YouTube channel. It's me Abdullahlata. Okay, so definitely previous video I talked about displacement time graph and velocity time graph. Okay, I definitely gave you the concept regarding. Now we are going to apply that concept. Okay, we are going to solve some questions regarding displacement time graph. Now first of all, student, remember this graph has been given to you, okay, and what is the question? Describe the motion of the car at each stage, means at A, B, C, D to E and E to F. Now how you are going to solve this question? Always remember, student, you have to definitely see the previous video, okay, definitely get the concept, okay, or I will definitely explain you. Now you are going to see that, okay, in displacement time graph you have to see that, okay sir, A is basically horizontal line. A is at horizontal line, okay, horizontal line. It means that body is at rest. Okay, now you can see that A means displacement is 40 meter from O, means starting or origin. Velocity is 0. I told you na, at this point is speed or the velocity is 0. If the examiner give you speed time graph, definitely you are going to apply. If the examiner give you distance time graph, you are going to apply speed is 0. If the examiner gave you displacement time graph, student, you are going to write velocity is 0. Always remember, if you are going to see horizontal line, it means that, sir, velocity is 0 and displacement is 40. I hope your concepts are clearing. Now focus. What about B point? Student, you are need to focus. B is basically the straight line. We are not going to see this area, student, okay? Okay, we are going to see this area. This area is basically, I told you student, this area is for uniform speed, okay, or uniform velocity. If you remember, I know you are recalling your concept. B means definitely you are going to see displacement is 66 meter from O and velocity is uniform. Now you are getting the concept. If you are seeing that a straight line is there, sir, straight line is at A, it means that sir, horizontal line is there, it means that sir, velocity is 0. But if you see this type of line, it means that velocity is uniform, speed is uniform, and displacement definitely you are going to. Why I am writing in these 2 points, student? Always remember, the examiner asks you to write the concise and precise language. You are not going to write the whole language. You are giving certain lines, 1 to 3 lines, where you are going to write. The concept is main thing, displacement and velocity you are going to write. Now, what about C, student? What about C? C is basically student at the maximum height. At the maximum. So you are going to write displacement is 90 from O. Okay, or you are going to say at this point again it is at rest point. It is at rest point, velocity is 0. And now, student, always remember, now from D to E. Now we are going to calculate, student, this point. Okay. Now see how you are going to calculate, student. Do remember one thing: slope is going down. Slope is going down, and this is not uniform. Student, curve is there. You are going to see curve. Okay. Curve means non-uniform. Curve means non-uniform, student. It means that sir, car travel in the opposite direction. Student, if you remember, this is the opposite direction. Opposite direction, number 1 point you are going to write. Second point, displacement decreases at a decreasing rate. It means that displacement is decreasing. Definitely it decreases from 90 to definitely here at 40, and 40 below 28. It means that displacement is decreasing at a if you remember this graph, student, I told you in my lecture, this graph is showing that sir, speed is decreasing, displacement is decreasing. Okay, if you remember my concept. Now at third point, velocity is non-uniform and decreasing. I told you that velocity will be uniform only this line. When we are dealing with curve, it means that velocity is non-uniform. Again, I am repeating the concept, don't worry. First of all, you are going to see, sir, this graph, this is the curve, okay, this is a curve. Definitely, sir, if the curve displacement will be decreases from 90 to 28, number one point. Second point, sir, this is curve. It means that, sir, velocity is not uniform and it is decreasing. And third point, you are going to see, sir, displacement decreasing at a decreasing rate. I hope the concept are clear. If graph mentioned you this graph, this is the line, student, this is means velocity is increasing at an increasing rate, displacement increasing. I know, I told you now, you need to note it down each and every section in your copy so that you can solve this type of question easily, okay. Now from E to F, what is happening, student? E to F, again, sir, it is a horizontal line. Again, sir, velocity is 0. What is the displacement? Is definitely 28. Okay, so you are going to see the displacement remain 28 from 0 and velocity is 0. If you are going to see the horizontal line, student, velocity is 0. If you are going to see this straight line, means uniformly increasing, and if you are going to the straight line is decreasing, it means that velocity is decreasing uniformly. Or if you are going to see this graph, means increasing, okay, velocity is increasing but non-uniform. If you are going to see this graph is decreasing, student, you are going to see that velocity is decreasing at a decreasing rate. Are you getting or not? Moving forward, student. So students, displacement time graph, now we are going to calculate value, okay. Examiner gave you this type of graph in the exam. Definitely find velocity displacement time graph at OA, AB and BC. Student, always remember how you are going to calculate this type of question. OA, okay, OA means you are going to find, always remember, student, OA means you are going to find out the slope. Always remember, slope means change in y upon change in x. Change in y, y2 minus y1 upon x2 minus x1. How you are going to get it? This is basically, and this is basically, okay. You are going to see this is 10, y2, y1 is 0. Then you are going to see x2 minus x1. Definitely you will get the answer 1 meter per second, okay. Now for AB, student, always remember at AB you are going to see displacement is 10. Again B has same displacement, means 10 minus 10, you will got the answer 0. Always remember, student, whenever you are going to see horizontal line, always remember, whenever you are going to see horizontal line, velocity is 0 always, and whenever you are going to see this line, definitely velocity is uniform. Now how you are going to calculate BC? Very easy, student. You are going to see 15 minus 10 and 20 minus 15. See, 15 minus final y2 minus y1, y2 x2 minus x1. Always remember, you will get the answer 1 meter per second. Student, these type of question, once you are going to revise it again, definitely you get the command. Now first of all, student, do remember the concept of displacement time graph. Student, this is the examiner question. They ask you, okay, which definitely car travels, A travel faster, okay, or B travel, okay, which one travel faster, student? So do remember one thing, student, you are going to see the angle, you are going to see the angle, okay, from time. This is theta 1, this is theta 2. You are going to see A definitely has greater angle. Student, do remember B concept. A has greater angle than B. Definitely it means that if any car has greater angle, or if any object has greater angle, it means that it has a greater slope, it means that it has a greater speed. Remember my word, you are going to see this thing. If theta is greater, it means that slope is greater. Slope is greater means you have velocity is greater. So you are going to see theta 2 is greater than theta 1. Definitely slope will be greater and definitely speed will be greater. So in the exam you are going to say, yes sir, car A move faster than the car B. Definitely car A has greater angle, it means that it has a greater slope and definitely it has a greater speed, okay. This is the concept which will solve definitely in your past paper solving questions. Displacement time graph. This is another example we are going to solve it. Let's see. You have been giving find velocity in this region OA, AB, and BC. Okay, how we are going to calculate, student? Uh, Always remember we are going to see this one x1 and y1. I have written x1, y1 0, x2 and y2 is basically 10. Okay. Now we are going to apply the formula. Now y2 minus y1, 10 minus 0, 5 minus 0. I got the answer positive. Speed I am getting the positive. Always my student, if you are going to see this line, it means that slope will be positive and speed will always be positive. Always remember, constant, uniform, always. Now we are going to find out the velocity across AB. I know it is a horizontal line. I will get the answer 0 because body is at rest. But let's suppose we are going to apply the formula slope. How we are going to apply? This is definitely y2 10 and y1 also 10. If I apply the formula, I get the answer 0. Displacement is not changing. It means that how we are going to get the answer across BC? Student, always remember one thing. This is x1, this is x2. As the time goes, okay, so we are going to take this time. Always remember, x1 is 15, y1 is 10, x2 is basically 25, but y2 is basically 0 because it is touching x-axis. Now I need to apply the formula y2 minus y1 and x2 minus x1. I got the answer negative. Always my student, whenever you are going to see this type of it means that sir, you have a negative slope and you have a negative speed as well. Okay, so this is the proof. One more thing, definitely students are there to understand the concept. Student, always remember one thing. If you are going to see if the angle is less than 90, always remember student, it is called as acute angle. Okay, acute angle. If the angle is less than 90, student, always remember you will get the positive slope. Always remember, and the speed definitely positive. Remember my word. Okay, if the slope definitely angle is less than 90, always less than 90. Okay, less than 90. Now if you are going to see if theta is greater than, let's see, this is the angle, student. Okay, this is the angle. Definitely this angle is greater than 90. It means that you will get the slope negative. You will get the slope negative. This is the basic concept, student. Always remember, angle is less than 90, you will get the positive answer. Angle is greater than 90, student, you will get the negative answer. Okay, by just seeing this concept, you are going to apply this concept in a difficult questions. Okay, so student, now you have been given displacement time graph and you need to convert into velocity time graph. That yesterday I explained you how to convert in a displacement time graph into velocity time graph. If you didn't watch it, you are going to see the previous video. Okay, now displacement is 20 and time is 5. You are going to, student, one by one you are going to apply the concept. First of all, sir, theta is not changing. See, theta means angle is not changing. It means that sir, speed is constant. First of all, do remember one thing. Speed is constant. It means sir, k velocity is constant and theta is constant. Number one. Second, sir, now we are going to apply the formula. Change in y upon change in x. Always remember this is x1, y1. x2 and y2 is definitely 0. Okay. Now if I need to apply the formula y2 minus y1, x2 minus x1, I got the answer minus 2 meter per second, but it should be, student, remember, constant. Okay. Now if I am going to see the velocity time graph, focus, remember student, these are important concept. This is velocity time graph is positive. I got the answer negative. Definitely this cannot be acceptable. Okay. Second one, Student, again positive, but it is definitely uniform. Definitely, I don't need the positive answer. I need the minus answer. Now this C and D I am gonna see. Let's see, student. C is basically -2, but student, remember this is increasing. This is increases. I don't want the increase answer. Definitely. Now this is -2. This is horizontal line. It means that in velocity time graph, horizontal line means it is not changing. It means that I got the constant because angle is not changing. Angle is not changing. So in that way, student, you are going to do the question. Remember concept. First of all, apply this formula. Theta is constant, velocity is constant. You are going to find out the slope. Then you are going to convert into velocity time graph either the positive, negative, or the constant. Are you getting or not? Time graph question, student, we are going to solve. Let's see. This is the question. Okay. And you need to find out the velocity time. Student, remember one thing, in exam you need to divide the section, okay, so that it will become easy for you to identify. Let's see, this is the question, okay. So you need to divide into section. First of all, from 0 to 5, what is happening? 0 to 5, student, always remember this is velocity time graph. It means that this stands for uniform. This stands for uniform velocity, okay. Definitely slope will also be positive, okay. Now you are need to find out the acceleration, because now acceleration means final minus initial. Now how you are going to find a student? This is the initial point. X1 is 0, and definitely y1 we definitely got the 0, and x2 definitely we have 5, and y2 we have definitely 15. Okay, student. So now we are going to apply the formula of acceleration. We know that final minus initial velocity. Final velocity minus initial velocity divided by final time minus initial time. I got the answer 3 meter per second square, which is definitely positive. Speed is positive. It means that acceleration is positive. Okay. Now uniform to remember. Now what about from 5 to 10, student? Always remember, now this is basically the curve, okay. This is basically velocity increases from 15 meter per second to 20 meter per second at a decreasing rate. Always remember, student, this is the graph, okay, at a decreasing rate. I told you in my lecture that you are going to see that speed, your velocity is decreasing. Always remember, velocity is decreasing. Acceleration is non-uniform and decreasing, okay. Do remember my word. Whenever you are going to see this curve, okay, so acceleration will also be decreasing and non-uniform. Moving forward, student, we are going to see from 10 to 15. Now do remember, student, 10 to 15 we do have a definitely horizontal line. What does it mean? It means that velocity is uniform, okay, and it is maximum. Just like in displacement time graph, I told you this is the maximum point. Similarly, for velocity time graph, we have velocity is maximum. Straight line means we have maximum velocity, okay. Now you know that at this point acceleration will be 0. Now how we are going to calculate, student? Final minus initial upon time. Let's see, student, in this thing, student, from 10 to 15, student, do remember one thing, here is also 20 meter per second. In this point also 20 meter per second. It means that no velocity has been changed. Let's see, final 20 minus 20, I will definitely get the answer 0 meter per second square. Acceleration, okay, you are going to see the graph. Uniform graph definitely stayed positive. This is definitely acceleration is decreasing, okay, velocity is decreasing. Non-uniform, this is horizontal line. When we deal with displacement time graph, speed is 0, if you remember my concept. Now here is definitely velocity is maximum, but acceleration is definitely 0. This is acceleration. Now moving forward, from 15 to 20 student. Velocity decreases uniformly from 20 to 0. Maximum velocity we have 20 meter per second. Now the graph is coming down. Student, always remember, I told you this is uniform, I know, but we are going to see that, okay, sir, acceleration I will get negative. Okay, we are going to prove it. 0 means final time, definitely final velocity minus initial velocity, final time minus initial time. I got the answer minus 0.4 meter per second. Okay, uniformly increasing, uniformly decreasing. If you are going to see from this graph, student, over here, see student, this is 20. Okay, this is final, the different time, this is initial time. So x1 is 15 and time is, as velocity we have definitely y1 is 20 here, x2 is 20 and y2 definitely we have 0, because at this point velocity is 0. That's why I have written over here velocity decreases from 20 to 0. Now you are getting it. Final means 0. Final means 0. 0 minus 20, definitely minus 20, divided by time we have 5, so minus 4.0 meter per second. So I know I am explaining with the help of graph as well and with mathematical calculation simultaneously, so that you can understand. Okay, now 20 to 25, student, now focus on this. Is the point, again, this is the point, horizontal line. It means that both velocity and acceleration are 0. Definitely at this point no acceleration, no velocity. Why? Because body is at stationary. At this point, student, at this point, this is the maximum speed and this is the stationary point, always to remember. Okay, this is stationary point. Now from 25 to 30, again you have a uniform velocity from 0 to 10 meter per second. Student, remember acceleration is uniform and you got the answer 2.0 meter per second square. Then 30 to 35, again student, there is a curve, there is a curve you have. So when you have a non-uniform, velocity decreases from 10 meter per second to 0 meter per second and at a decreasing rate, number 1 point, and acceleration is non-uniform and student, in this way you are going to write the point in our CIE exam. Remember my words. Okay, you are going to write in this way. Displacement time graph, you will need to explain the displacement and the velocity. When you are dealing with the velocity time graph, you need to explain the velocity, you need to explain the acceleration, you need to explain the uniform or non-uniform graph. In a detail wise you are going to explain it. Okay, student, velocity time graph we are going to discuss in detail concept, because students are asking that, sir, why it is happening, why the velocity is constant and why the velocity is not constant, why the graph is uniform, why the graph is not uniform. Now we are making this video in detail. Now student, do remember one thing. If you are giving velocity time graph, student, this is the line which we call as basically uniform. Okay, constant. How we are going to say, student? Why? Because angle theta is not changing. Angle theta is not changing, is constant. If theta is 60, this is also 60, this is also 60. If theta is not changing, number 1 point, velocity will also be not changed. Remember why? But velocity will remain constant, with same. Number 2 point, now slope also remains constant, because you know that slope is change in y upon change in x. What is y? Change in velocity upon change in time. So definitely we got the answer, acceleration. So if the slope remains constant, the acceleration is also remains constant. Okay, so definitely you will get the acceleration positive. Student, do remember these points are important. When you are going to see that angle is not changing, number 1, without calculation, you don't need any calculation, you just need to apply this concept and got the answer in P2 and P4. Remember my words. Number 1, theta is not changing, sir. Velocity is not changing, it means it is constant. Sir, slope remains constant, it will become, acceleration will become positive. Simple, so easy. Now here, similarly, if the speed or the graph is in a decreasing, uniformly decreasing, okay, uniformly decreasing, okay, Now, angle again is not changing, number one thing, but you can see velocity remains a negative. Velocity will get negative, okay, and slope is definitely negative, and definitely acceleration will get negative. Definitely, if you get the answer, a slope is, if you are getting the slope is negative, definitely speed will be negative, and if you got the two answer negative, of course you will get the answer acceleration will also be negative. Okay, so once you are going to see the graph is going up, angle of theta is not changing in a positive way, definitely positive. If the graph angle is not changing in a decreasing way, definitely you will get the negative answer. Okay, now case number, the student, case number 1 2 mostly student understand, but student case number 3 and case number 4 are confusing. Now velocity time graph, student, always, now this is the basically increasing graph. How you are going to see, student, see theta, student, is less than 90. How we are going to calculate, student, this is the point. Okay, we are going to definitely draw the tangent line. Okay, if you remember my words, tangent line we need to draw. Theta is basically less than 90. If theta is less than 90, I explain you, it means that velocity will be positive. Remember my words. And if theta is increasing, if you are going to see theta is changing at every point, theta is not constant in a straight line. No, theta is changing. It means that slope will be changed. It means that velocity will be increasing, then you will get the acceleration positive. Remember my word, you are going to see that theta is changing. Before question, theta is not changing, that's why velocity remains constant and acceleration will get positive or negative. But here you are going to see that the theta is changing continuously. Slope theta is increasing. Number one point, theta is increasing. Number one point. Second point, slope is increasing. Third point, sir, velocity is increasing. Definitely acceleration will be positive. Okay. Now case number 4, student, if you remember this graph, okay, if you remember this graph, okay, now you are going to see, sir, okay, sir, at this point we are going to see, sir, at this theta, again we are going to calculate this point, theta is decreasing, student. Here theta is increasing, okay, here theta is decreasing. Angle again less than 90, velocity will be positive, or you can say theta is decreasing. If theta is decreasing, it means that velocity will be decreasing, and if the velocity will be decreasing, definitely acceleration will be negative. This is the basic concept where theta is increasing or theta is decreasing. Now this is for you, student. If you are going to see in this type of curve, okay, you are going to say concave upward means acceleration positive, and if you are going to see this curve means downward. Parabola, see, parabola is downward, here parabola is upward. Okay, I told you where acceleration is negative. You are going to make this in your copy and write in your copy to conceptually understand. Theta is increasing, velocity is increasing, slope is increasing, definitely acceleration positive. Theta is decreasing, velocity is decreasing, acceleration will be negative, definitely. Now if you are going to see velocity and acceleration have the same sign, positive positive, let's suppose, see, speed will be increased, or they have the same sign, negative negative, speed will be increasing. But if you are going to see the opposite sign, velocity increases but acceleration positive, it means that the speed will be decreased. Okay, now we are going to solve one past paper question. Okay, and I hope you can solve it by yourself. Okay, now this is one of the past paper question of distance time graph. Okay, let's see, you have given this question, okay, and you are solving this question, and I am giving you 1 minute, okay, and you can definitely pause that video and definitely confirm your answer. Okay, that's the main point. Okay, I hope you have done your question, okay, in your copy. Now always 0 to 5, student, now do remember one thing, 0 to 5 is a basically this graph, and I told you it is, sir, angle is changing at every point, it means that, sir, increasing speed, splendid. Okay, now 5 to 7. Sir, this is, you told us in the lecture also, constant and uniform. Explained it. Uniform speed, and you can say student constant also. Okay, constant speed. Okay, I hope you are getting it. Now 7 to 12 student. Now you are going to see this is basically angle is changing, speed is decreasing. Very good, decreasing speed. Okay, we are not dealing with it is a uniform or non-uniform. If you want to write, very good. Non-uniform decreasing speed, very good. Okay, okay, you can write okay non-uniform as well. Okay, now 12 to 15. Now what is this? Distance time graph. Distance time graph. This is body is at rest or stationary. Very good. Rest, and in some students write stationary, both are right. Okay, stop, you are not going to say. Now 15 to 17, again very good, uniform and constant speed. Okay, very good. 17 to 20, again this is rest and stationary. Okay, so I hope student you did the question in the right way. I know my students are intelligent and smart, and you can confirm the answer. Thank you.